Welcome in the fifth section of our course. In this section, we'll be looking at the concurrency and multi-threading with Java. So we'll be covering two most complex but also most important aspects in the context of performance from Java ecosystem. So let's see what we will cover in this section. At the beginning, we'll be looking at the parallelizing computations with Streams.parallel. Next video will be about choosing parameters for executor service. Third video will be about using computable futures for async operations. Fourth video will be about leveraging compare and set for non-blocking operations. Last video will be about stock walking API for fast access of thread stack trace. So we'll be looking at the new API that was recently introduced in JDK. This is a first video in which we'll be parallelizing computations with Streams.parallel. So at the beginning we will be writing map logic using Stream API. Then we will be using Parallel to speed up our logic, and finally, of course, we will write performance tests for both approaches to have actual numbers that will be used to compare both approaches. So we will be creating series of methods that will be using Streams API, Parallel and Normal API, and we will start performance tests for them. So as always, we are creating two variations. We will lower it for the test purpose, and we are creating ArrayList. ArrayList is a collection that will be backed from our stream. So we'll be using ArrayList underneath when doing stream computations. In a setup, we are just iterating over length, so parameter is taken here, and adding elements as in previous sections. So first method that we want to test is API map. So let's focus on the mapping. First, our test is testing normal version. So we are just taking a stream from backing ArrayList. We are mapping every element by multiplying it, and finally we are collecting it to list. That list will be consumed by black hole. Next test is test of the same map, so we can see that multiplier and also collect, but here we are issuing parallel stream. So the execution will be executed in parallel. We will be leveraging fork join pool, and fork join pool by default has as many threads as you have cores in your CPU. So it will be distributed among multiple physical CPU cores. Next method that you want to test, and that is also useful and used very often, is sorting. So we'll be sorting our stream API. So we are taking a stream, sorting using sorted. We are using integers, that's why we don't need to pass explicit comparator interface, because integer is already implementing comparable. So we can see here, if we will use the stream on the non-implementing comparable type, we will need to pass specific comparator here. So there is a sorted with comparator version. So first test using normal stream, second one using parallel stream, you can see, and logic is the same. So let's start the test, and we will see differences between executing our parallel stream, so fork join pool, multiple threads, multiple cores, and difference between sequential approach when we're using only one CPU core. We can see that after some time we have our results. So let's compare every sequential operation with parallel streams approach. For the 1000 elements sequential approach, we have 6 microseconds per operation. And when we will compare it to the stream API, we can see that it took 49 microseconds. So it is 10 times slower to do map in parallel. So it could be a bit counterintuitive, but the coordination cost and synchronization between threads is very high. So we can see that for the low number of elements in our collection, it is not efficient to use parallel streams. Let's see how situation presents in 20,000 elements. So we can see that here our map took 181 microseconds per operation, and in parallel took 151. So we can see that in this example, when we have longer collection with 20,000 elements, the parallel map is faster. So there is some kind of threshold that after which you will cross it, there is better to do parallel API. So also let's compare sort. So we can see that sorting for 1000 elements for sequential took around 100 microseconds per operations, and sorting for 1000 for parallel 2 times more. So we can see also for sorting there is the same behavior, but let's see how sorting for 20,000 elements does look like. So sequential version took 3000 microseconds, but parallel version took 1300. So it is almost 3 times faster. So the same situation when you have more elements in your backing array or list or anything, you can go ahead with parallel stream approach. Otherwise, if you have small collections, you should use normal stream approach.